Hi friends. So you have been promoted into your new class 8th standard and I will be taking chemistry for you. We will be discussing the theories of chemistry in this chapter, in this class. So the first chapter which we are going to discuss is metals and non-metals. Okay, so in our day-to-day life we are dealing with a lot of metals, a lot of non-metals. So just think of some examples of metals which we are using in our daily life. Metals. Okay, so the ornaments which we use, the knife which we use in our kitchen, the plates, the vessels, etc. A lot of examples are there and you can note it down in your notebook, the examples of metals which we are using in our daily life. Likewise, there are a lot of non-metals which we will use, which we are using in our daily life for our different purposes, isn't it? So these metals and non-metals are an inevitable part in our life. These metals and non-metals will help us to lead a good life, a happier life, isn't it? Okay, so we will be discussing the properties of metals, the properties of non-metals in this chapter. Okay, so first of all, let us study which are the characteristics of metals. So as we know, gold, etc., gold, aluminum vessels, then what? Lead. Okay, so these gold, aluminum, etc., these metals are usually solids. Usually they are solids. Usually. Okay, there are some exceptions that we will study it in the later classes. Anyway, the common properties we will be discussing today. So the metals are usually solids and they are hard. Solids, as usual, we know it is hard. It's very strong. The metals are very strong. Okay, then most of the metals are lustrous. Most of the metals are lustrous. They are solid, they are hard. Most of the metals are lustrous. What do you mean by luster? Luster means shining. To shine. To shine. That means they are all shiny. Metals are usually shiny. Their properties, they have a shining property. Okay, so metals are lustrous, then they are ductile. Ductile means what? They can be made into wires. Copper wire which we use for our the electrical wiring which we use. They are wires. That metal, copper metal is being turned into wires, thin wires. Okay, so the metals are easily made into wires. So that's a good property of metal. So these properties are helping making our life more easier. Okay, it's giving a lot of advantage to us in our day-to-day life. Okay, so metals can be made it into wires. Then what is it? Then the malleability. What do you mean by malleability? What do you mean by malleability? Malleable. Like metals are malleable. They have the property of malleability. What do you mean by that? That means they can be made it into sheets. They can be made into sheets. Okay, so like we can make a metal piece into a wire, we can stamp it, and what we can do, we can make it into thin sheets. Okay, that's another property of metals. And the main important property is that metals are having high melting point and high boiling point. Metals are having high melting point. That means melting means what? Solid is melted into liquid. Boiling point means what? The liquid is converted into gas. When we are boiling water for our tea, at 100 degrees Celsius, the water will start to boil and the water vapors will be evolved. That means the water in the liquid form is converted into liquid, means what? It's converted into water vapors in the gaseous form. That is boiling. Okay, ice, it melts into liquid, water. Ice which is in the water itself in the solid form is called ice. And this ice, it will melt at 0 degree into water, isn't it? Okay, so the conversion of solid into liquid, liquid into gas, the metals are having high melting point and high boiling point. That means we have to supply a lot of energy in order to convert a metal into liquid and a metal which is in liquid form into, when we convert a solid metal into liquid, and then these metal in the liquid form, if we want to boil it, we have to supply again a lot of energy, then only they will be converted into what? Gas. Okay, so what we have to understand is that they are having high melting point, high boiling point. Okay, then another important thing is that they are good conductors of electricity. These metals are good conductors, very good conductors of electricity and heat. Electricity and heat. Okay, that's why we are using copper wire. Copper is a metal. Copper wire for electric wiring. That means it will pass electricity through it very easily. We can pass electricity very easily through these metals. So metals are having most of the metals are having good conductivity property. Most of the metals are having good conductivity property. They will conduct heat energy. They will conduct electricity. Okay, so these are the main important points of metals. Okay, now we will discuss the important points of non-metals. The important points of non-metals. What are they? What are the important points of non-metals? The non-metals, they can be solids, liquids or gases. They can be solids, liquids or gases. Clear? They can be solids, liquids or gases. Then most of the non-metals are soft. In the case of metals we have studied it is hard, but here most of the non-metals are what? Soft. Okay. Then there one exception is there. One exception. A non-metal which is the strongest or the hardest non-metal in the universe is diamond. The smallest, the hardest non-metal in the universe is diamond. And which is a non-metal? Diamond is a non-metal. It's a form of carbon. Carbon is a non-metal. And another form of allotrope, we will study it. It's an allotrope of carbon. Allotrope means different forms. Different forms. Carbon is having different forms. Allotrope of carbon is diamond. Another allotrope of carbon is graphite, which is again a non-metal, and this is soft. Graphite, the lead which we use for what? For writing what? In a pen, we use graphite in pencil. That lead, it will be broken easily, isn't it? Okay, so that is a non-metal, they are soft. But another form of carbon, the same form as that, means the graphite and diamond are made up of same material, that is carbon. But the form changes, the property also changes. That means diamond is the hardest non-metal. It is not the hardest element in the universe, which is a non-metal. That's an exception in the case of this property. Most of the metals, non-metals are soft except diamond, which is the hardest metal. Clear? Then what we can say is these non-metals are not lustrous. They are not shining. We cannot make non-metals into wires. We cannot convert non-metals into thin sheets. Clear? They are not ductile, they are not malleable. Okay, then non-metals have low melting point. Low melting point and boiling point. Non-metals usually have low melting point and boiling points. Clear? Then what we can say? Okay, so these are the physical properties. While we are seeing with an eyes, we can understand, we can distinguish the properties of metals and non-metals like this. Clear? Okay, so these are the important points to be noted down. The physical properties of metals and non-metals. Metals are hard, they are solids. Exception of a metal which is liquid is at room temperature. Which is liquid at room temperature is mercury. Mercury is a metal which we use in a thermometers. We used to check our temperature, body temperature, the thermometer. Inside that there is a bulb, a shining thing you will see under it, a grey color shining thing. That metal is mercury. That's a metal, but it is in the liquid form. Okay, that's an exception for a metal which is not in solid state. Clear? But most of the metals are solids. Then what it is? They are hard, they are solid, they are lustrous, they are malleable, they can be converted into thin sheets. Then what? High boiling point and melting point, they are good conductors of heat and electricity. And the opposite of these properties, we will say what? They are soft. The non-metals can be solid, liquids or gases. they are not lustrous, they are not ductile, they are not malleable. The non-metals in the gas or liquid forms have gas, in the solid and liquid states have low melting point, low boiling point. Clear? So, I hope these things are clear to you. Now, we will be moving into the chemical properties. Now, till now we were discussing the physical properties. Now, we are discussing the chemical properties. The chemical properties of metals. The chemical properties of metals. Okay. So, the first and the foremost thing, first reaction, chemical reaction is reaction with oxygen. When a metal react with oxygen, for understanding I will make it more clear. Reaction with oxygen means what it is just burning. When we burn any metal in air, we just take a metal, we burn it, that burning is happening in the presence of air. Inside air we have oxygen. So, whenever it is burning, it will react with, it will combine with what? Oxygen. The metals will combine with oxygen. Very important, metals will combine with oxygen while they are burning. That is called, termed as what? Reaction with oxygen. So, metal, when it is solid state, when it is reacting with oxygen, O2, or let us write oxygen itself. Metals, when it is reacting with oxygen, what we will get? We will get metal oxides. Metal, when it is reacting with oxygen, we will get metal oxides. Clear? So, reaction with oxygen means think or understand that it is just burning. Okay, we will show it into a flame. We will take a metal piece. For example, magnesium. Magnesium is a metal. We are denoting it by the letter Mg. Magnesium, when it is reacting with oxygen, we will burn magnesium. It's in the form of a ribbon. We will get it in the form of a ribbon. Okay, magnesium metal ribbon, we will get it. So, if we cut a piece of that ribbon and if we keep it in the flame, it will start burning. It will start burning with with the flame, and after that some ashes we will get. That means when it is burning, it will combine with oxygen. It's changing its shape into soft ashes. Okay, after we burn some in the kitchen and all, if we are using firewood, after burning we will get ashes. The same way, the metals after burned, it will be converted into ashes. That ashes are called metal oxides. In the case of magnesium only, that ash we will call it as metal. When it is reacting with oxygen, we will get magnesium oxide. Magnesium oxide. Metal, when it is reacting with oxygen, we will get magnesium oxide. In the case of magnesium, it is converted into ashes. Clear? So, magnesium oxide, again it is solid, this is gas. Okay. So, metal, when it is reacting with oxygen, we will get magnesium oxide or metal oxides. In the case of magnesium, it is in the form of ribbon. If we cut a small piece of ribbon and if we burn it in air, what will happen? They will be converted into ashes, and that ashes are called magnesium, oxide of magnesium. Whatever it is combining with oxygen, we will call it as oxides. So, that oxide of magnesium is produced when it is reacting with, when the magnesium is reacting with oxygen. Is it clear? Okay. Another example, if we want to understand it more clearly, another reaction, copper. Copper, it's a metal. Copper is a metal, solid. It's reacting with oxygen to form copper oxide. You are balancing it. But I have written 2 here. 2 copper molecules, atoms I have taken. In 1 oxygen molecule, I have got 2 copper oxide molecules. Clear? Okay. So, that you will study it in your higher class. So, anyway, copper, it is burned in air. What we will get? Copper oxide. So, whatever metal, when it is burned in air, it will react with oxygen and we will get metal oxides. That is clear? Okay. Now, the next reaction, this is the first reaction, reaction with oxygen. The next reaction is reaction with water. What is the next reaction? Reaction with water. Okay. So, whenever any metal, when it is reacted or when it is mixed in water, or maybe we will take the metal in a water containing vessel and we will burn it. So, it is reacting with water. Okay. Whenever metal react with water, what will happen? Metal, when it is reacting with water, we will get, in case of some metals we will get metal oxides, in case of some metal we will get metal hydroxide, metal hydroxides. In some cases we will get metal oxides and in some cases we will get metal hydroxides plus hydrogen gas. Hydrogen gas will be evolved. That means whenever it is burned in, when we mix a metal in water, they will be converted it into metal oxides or metal hydroxides plus hydrogen gas will be produced. Like when we are opening the soda cap, there will some brisk effervescence, we will hear the sound and the water will be coming up. That water is coming up, means what? Which is rising up just because of the presence of carbon dioxide gas. The carbon dioxide gas is coming out, with that the water, the liquid is also rising up as brisk effervescence. Likewise, there is hydrogen gas evolved. In the case of soda, the carbon dioxide gas is evolved, it is coming out. Likewise, hydrogen gas will be coming out in this reaction when a metal is reacting with water. Okay. For example, sodium. Sodium is a metal, soft metal, sodium. Okay. This is another example. Sodium, it's a example of exception for metals being hard. This sodium is not a hard metal, it is a soft metal. Another example. Mercury was the metal in liquid form. It was not a solid, it was in liquid form. This is not a hard metal, this is a soft metal. The softest metal is sodium. Okay, exception. Okay, sodium when it is reacting with water, what we will get is sodium hydroxide. When we write it as OH, it is hydroxide. Sodium hydroxide plus H2 gas. Sodium hydroxide plus H2 gas. Is it clear? Okay. So, whenever a metal is reacting with water, what we will get? We will get metal oxide plus metal hydroxides. And why this reaction happens, how this reaction happens, why this sodium is combining with this oxygen and hydrogen, these things you will be studying it in your next class, in your higher classes, 9th standard, 10th standard, etc. The phenomenon of reaction, why reaction happens, how reaction happens, these things you will be studying it in your higher classes. So, now you just have an idea that the metals can react with oxygen, the metals can react with water, they will be forming metal oxides or metal hydroxides. Clear? These concepts you keep it in mind. Why and how we will study it in your higher classes. Okay. So, some more examples if I write. Sodium hydroxide, calcium plus water, what we will get? Calcium hydroxide plus hydrogen. Calcium hydroxide plus hydrogen gas. So, these are the examples or the reactions of metals with water. Okay.